Lecture 22. In this lecture, we will be interfacing 7-segment LED and will be interfacing an LCD displays. We have already discussed about what is a 7-segment display, what is an LCD, how it works. In this particular, and we have already discussed about the two boards, how you will be interfacing with Arduino board and with STM board. In this particular lecture, I will be showing you the circuit diagram and the code that is required for interfacing the 7-segment display and the LCD. Okay? Okay. So, I will be showing you an workout example of a 7-segment display, and also I will be showing you an workout example of an LCD display. And make sure that I will be showing this one for 7-segment display both using STM board, the circuit diagram, as well with Arduino board, and also the same thing I will be doing for STM and Arduino. So, this is how this lecture will go on. Okay. The first example that I will be showing with 7-segment display unit to the STM32 board and display the characters from 0 to 9 in a cyclic fashion with a time delay of 1.5 second. Okay. So, what will happen? That we already know how a 7-segment looks like, what it works. So, what it will do is like that, it will display first, let us say it will display 0, this is 0, then it will display 1, then it will display 2, then it will display 3 and so on. Okay. It will go on doing this with a delay of, here there will be a delay of 1.5 second. Again there will be a delay between 1 and 2, 1.5 second and so on. Okay. And I will be connecting this from segment A to G of the data output pins D2 to D8 on the Arduino connector using this STM board. Now, this is the typical circuit diagram that is there. You can see this is the common port. Now, this is a common anode 7-segment. We already discussed about common anode 7-segment and common cathode 7-segment. This is a common anode 7-segment where the common port is connected through a resistance to 5 volt of STM, and all other ports, that is A, B, C, D, E, F, G and DP, these are connected to pin D2 to D8 of this STM board. Okay. So, now you can see the connection. A is connected to D2, A is connected to D2, B is connected to D3, C is connected to D4, D is connected to D5, E is connected to D6, G is connected to, F is connected to D7 and G is connected to your D8. Okay. This is how we have made the connection. There is no hard and fast rule that you have to make the same connection, but this is how we have connected it. Okay. So, this is all about the connection. So, when you have this 7-segment with you and you want to connect it, you connect the common, if it is a common anode 7-segment, through the common point through a resistance connected to 5 volt, and all these points you connect to the ports of your STM. let us see the embed C code. Similarly, as I have told you, we have made available pins D2 till D8 starting from the segments that are connected, that is A, B, C, D, E, F and G. And in the same way we have given these names also for the digital output port. So, which is A, which is connected to D2, B is connected to D3 and so on. Now, it is a common anode segment. When this segment will glow, the common point is connected to BCC. This segment will glow when we pass a 0 value to this line. So, you have to pass in D2 through this A is the signal, you have to pass a 0. Then only this particular segment will glow. This is A segment. When this segment will glow? This segment will glow when you pass a 0 to this. So, to glow it, you need to pass a 0 because it is a common anode. If it is a common cathode, you have to do the opposite one. Okay. Now, there are 9 cases because I have told you I will be displaying from 0 till 9 with a delay. Okay. Let us first consider case 0. What is 0? This is 0. This. Now, you see how many segments will glow? All the segment except G. So, only the G segment will have value 1 and all other segments you want to glow, you have to pass a value 0. Similarly, that is what I have done. A is 0, B is 0, C 0, D 0, E 0, F 0, but G is 1. Okay. Similarly, for 1. For 1 it is interesting, you see for 1 you only need B and C to glow. So, B and C should have a 0 value, all else will have 1 value. You see B and C is having 0 and all others are having 1. So, you can do that for all others. Okay. I have shown you for 0 and 1. Similarly, you can try out with 2 to 9, it will be somewhat similar. So, this is the code that you have to write here, digital out, and this is the switch. Now, we will see what happens in the main phase of the program. In while 1, what we are doing? For I equals to 0, here what we are doing, for I equals to 0, I less than equals to 9, I plus plus. I am starting from 0 till 9 and when it becomes 9, it will be again in this particular loop, again it will become 0. And I am calling display of I. When you call display of I, it will go back to, where it will go back? It will go back to here and it will check this. It will actually go back to the previous one. Okay. Here it will go back and it will check for this case 0 and it will take this output, okay, and then it will break. Okay. And it will wait after that for 1.5 seconds and again it will do the next one. So, what it will do? It will starting from 0, it will go on doing 0, 1, 2, 3 up till 9 and when it reaches 9 again it will become 0. So, this is what it is doing. This display I am sending this I from 0 till 9 and again after displaying it is waiting for 1.5 seconds, again we are displaying it. So, it goes in a continuous loop. The next example is very similar, but with Arduino board. Okay. So, the previous example that we did is with STM board, this is with Arduino board. Things are pretty similar, but the only thing is that the code part will be little different from your STM. Okay. You have to again connect from segment here from A till F. till G, and digital pins D2 to D8 on the Arduino board. Let us see the circuit diagram. Again the circuit diagram will be the same. The common port of the 7 segment through a resistor will be connected with 5 volt of the Arduino Uno board, and digital pin 2 to pin 8 will be similarly connected from A, B up till F, up till G in this particular board. Okay. The same, the way we connected for STM, the connection for this will be the same. Now see the code. Here similarly we have, in the setup phase we have to specify the pin mode for each one of the pins. We are using pin 2 to pin 8, so we have to specify the pin mode of each one of these, and each one of these are all output. So we are making all the pins starting from 2 till 8 as output, and in the loop phase what we are doing something very similar. So let us say for I equals to 0, I less than equals to n, I plus plus, I am again displaying I with a delay of 1.5 second, which is 1500 here. But here for case 0 in STM we have seen that we have only written A equals to 0 or A equals to 1, it was working. But here we have to specifically write for all the pins here like this, one by one by. So we have to write these many times the digital write function to write for case 0. Again for case 0 it will be A, B, C, D, E and F, no G. So you see A, B, C, D, E and F, but not G. G is connected to pin 8, so it is not, it is high. Okay. Similarly you have to write the same way, like this is just for case 0, for case 1 till case 9. So for case 1 it will only be this and this. So it will be load to only B and C. B and C is connected to 3 and 4, and all others it will be high. So it will be similar for other cases. Now of course you have seen that writing again and again this digital write so many times is somewhat cumbersome. So an alternate program, okay, an efficient and alternate program could be something like this. For I equals to 2 to I less than equals to 8, I plus plus, pin mode we are writing I equals to output. So what will happen? First time it is 2, so it will be pin mode 2 comma output. Okay. Next pin mode 3 comma output, and so on. It will go on till 8. Okay. So in the initialization, instead of writing it so many times, we have just put up code for doing this. Similarly, in this on, in the on what we are doing for int I equals to 2, I less than equals to 8, I plus plus, we are writing digital write I comma low. So it will be like, if it is for these, we are on a first go we are writing low value to all the pins. For all the pins this is low value. Okay, that is what we are doing it. So we are writing digital write I, that is pin 2 low, okay, 3 low, all the value we are writing low. Now for display what we are doing? Display we are checking something. Now you see if it is 1 and 4, okay, we are writing value 2 to high, because for 1 basically it is this and this, okay, and if you see this and this, and for 4 it is this, this and this, Okay. So, what basically we are doing, if display equals to 1, okay, that means you want to display this as either this one or display equals to 4, then we are writing digital write to port 2 as high. Port 2 is connected to this and we do not want that to glow, okay, and as well as for 4 also we do not want that to glow. That is why when it is 1 or 4, then digital write 2 will be high. If it is 2, okay, let us take another one. If it is 2, this and this. You see, if it is 2, then this will not glow and this will not glow, okay. If it is 2, then we are digital writing 4 as high. Again, if it is 5 and 6, we are writing 3 as high. Similarly, again if it is 1 or 4 or 7, then we are writing 5 as high. Similarly for all others. So, here although we have to check so many conditions, but it is not like we have to write it the whole set of codes for all the things. So, this is one of an alternate program where we have shown another way how you can do that. Okay. So, we have used the simple way, the previous one, for experimentation. Okay. So, here is in the loop section what you have to do. While 1 for I equals to 1, I less than 9, I plus plus, we first call display I, then we call this delay and then we call this on, then we call this on function, okay, which is doing the required functionality that I have just discussed. Next I will move on and I will be showing how we can interface the LCD. Okay. The LCD has been already discussed in detail how it works. Now I will be just showing you again the circuit diagram and the code that we have used both for Arduino and for STM to dump it. Okay. So, what I will be doing in this example, I will interface an LCD unit to the STM32 board in a 4-bit mode. You already know what is a 4-bit mode, and display a fixed message on the screen of the LCD. We connect the 4 lines, that is D8 to D11 on the Arduino connector, and we connect this register select to input pin D13 and we connect this enable input to D12. These are the connections that are required for STM32. Okay. This is how the connection goes. If you see the LCD, it has got these pins. So, the pins are, this is VSS, VCC, VEE, RS, read write, enable, and then for the 4-pin mode we do not do anything with the least significant bit. We are concentrating on DB4 to DB7, and this is for the contrast LED and this backlight, sorry, LED and one is LED minus. Okay. So, how do we do the connection? The connection goes like this. This is connected, VSS is connected with this ground. This VCC is connected with this 5 volt. Then we have this VEE, which is the contrast. This is connected to a potentiometer. You see the input to this is connected to the out of this potentiometer, and one end of the potentiometer is connected to ground and another end of the potentiometer is connected to VCC. This is how we have made the connection. Okay. This is for the contrast light of this particular LCD. Then is the register select, which is connected to D13. Read write is permanently connected to ground because we are only writing here. enable is connected to D2, DB4 to DB7 is connected to D11 to D8, and finally this LED is connected through a resistance to 5 volt, and this, the next one, is connected to ground. This goes with the connection with STM. Okay. Now let us see the embed program. Here, instead of only including embed.c, we also need to include few other header files. The two header files that are required to be included for LCD interfacing is text LCD.h and text LCD scroll.h, and we have to use a function text LCD scroll, and we can create an object with the name LCD, and we connect the following pins D13, 12, 11. These are for the data bit line. And what kind of LCD we are using? LCD 16x2. The LCD that we will be interfacing, it's a 16 x, the type of this LCD. Okay. So this is necessary for LCD interfacing. So for any other things, when you interface this LCD, you need to follow up these steps. Next is the main program. In the while one, what we are doing, LCD is the object that we have created. We are using the function setLine. In the 0th line, we are displaying embedded system, and in the next line, we are displaying NPTEL 2018. Then we are waiting for, let us say, some delay, we are waiting for some delay, and again this whole thing repeats. Okay. So this is what we have also done. When we show you interfacing in the next lecture, you will see that it is displaying the same thing. But for that, you need to do that circuit diagram connection, and the following code needs to be executed. This is the next program, which is fairly similar, but only difference being here is that the scrolling speed we are specifying, where we are specifying 2 characters will be displayed per second. Till this part it is all the same, but here we have include LCD.setSpeed, which is 2, meaning 2 character will be displayed per second, and this code is the same, embedded system designed with ARM, NPTEL 2018. Okay. So this is what it is getting displayed here. And one important thing is that it is 16 character, the LCD that we are. So if the text is less than 16 character or equal to 16 character, it will be displayed. But if it is more than that, then what happens? This particular text will be scrolling. It will scroll down, okay, with the speed of this which is specified here, LCD.setSpeed. This is another program, similar program, just that we have made the speed as 3 characters per second. So it is another program. You will see that when we put this code into the board, it will start moving little fast. Okay. Next, I will be showing how do we interface the same LCD with Arduino Uno board in a 4-bit mode and display a fixed message on the screen. So here we are not playing around with too many things. So here we will be just displaying a particular text in the LCD using this Arduino. And how the connection goes, it goes like this. The 4 data lines will be connected from pin 8 to 11. The register select will be connected to pin 13 and the enable pin will be connected to pin 12. Similarly, as you have already seen that for the previous code for STM, we were using some header files, we were including some header files. In the same way, for Arduino, you have to do the following. in Arduino this text LCD function is already imported. It can be directly accessible in the example section. Okay. In this example section you can directly use it. Open the Arduino IDE and follow the steps. You go to File, then to Examples, then you will see Liquid Crystal. Choose any example, let us say Hello World example, and then use that. Modify the program according to your need. Like I will display NPTEL 2018 Embedded System Design with ARM. So, this will be displayed here. The description of the connection will load by default. Okay. This is how it will be displayed. This is the connection diagram which is quite similar. Same VSS, VCC, VE will be connected accordingly. This is the potentiometer through which it will be connected. This is the register select, read write directly connected to ground. These 4 pins will be connected to D8 to D13, and this LED plus and LED minus will be connected to ground and VCC through a resistance. So, this is all about the circuit diagram. So, this is the code. So, here also you need to include this particular header file, that is include liquid crystal.h. Same way, liquid crystal you make an object LCD and you just specify 13, 12, 11 and it will take accordingly. And in the setup phase you basically we do the following: LCD begin, we specify this 16 cross 2 LCD, LCD print we have given embedded system, LCD cursor 0 and 1 we have given, and LCD print the cursor will now move to this position and it will print NPTEL 2018, and we give a delay of 1 second and the same thing goes off. And this is the loop phase where we are calling this LCD.display with the delay of certain unit. So, we have come to the end of this lecture. So, in this lecture specifically I have discussed about 2 output device, one is 7 segment, another is LCD, and I have also shown you the circuit diagram both using Arduino and using STM, and how you can display any text using these 2 devices. We will move on and we will be showing the interfacing experiment now with this in the next lecture. Thank you.